What if our planet runs on a hidden timer, a rhythm older than civilization itself? Every 12,000 years, something resets. Ice sheets retreat, oceans rise, magnetic fields shift, and the world reorganizes its story. Scientists call it cyclical catastrophe. Ancient myths call it renewal. We just call it home. Still orbiting, still breathing, still unaware of the next breath. Tonight, we'll slow down to explore the clockwork patterns etched into Earth's crust and sky, from glacial layers to solar cycles, and ask the question whispered through time: are we living on borrowed calm? Before we begin, find a comfortable place to rest. Breathe slowly, and let your curiosity stay awake even as the body drifts. Where are you watching from, and what time is it for you right now? Beneath Greenland's endless white lies a library written in frost. Each layer of ice, pressed and sealed by time, keeps a chapter of Earth's shifting moods. As researchers lower their drills into the blue abyss, the sound is gentle, like a glass sighing under weight. When the cores rise to light, what they hold isn't just frozen water, it's air from worlds we no longer remember. Within those trapped bubbles are fingerprints of volcanoes, storms, and sudden changes that shaped the rhythm of life. For decades, scientists sliced these ice cylinders into moments: 1 centimeter for a century, 1 meter for 1,000 years, and measured trapped gases to trace Earth's ancient pulse. What they found startled even the most cautious minds. Roughly every 12,000 years, the data jumped. Dust storms thickened, temperatures swung violently, and the magnetic field wavered. It was as if the planet blinked, paused, and began again. At first, these clues felt like fragments without pattern, but as ice cores from Antarctica joined Greenland's record, the puzzle aligned. Across hemispheres, the same intervals repeated: 12,000, 24,000, 36,000 years, marking transitions between calm and upheaval. Yet, after each pulse, ecosystems revived, spreading green across rock and ash. The Earth, it seemed, was not breaking but breathing. Some researchers compared the cycles to the slow inhale and exhale of a living organism. During each inhale, glaciers expanded, drawing carbon and water into silence. During each exhale, warmth returned, rivers carved new paths, and species migrated like blood, returning to new tissue. This vision reframes disaster as renewal, rhythm as resilience. Standing on the ice shelf today, we inherit those hidden symmetries. Our technologies and cities rest atop the thin calm between pulses. It's easy to imagine stability as permanence, yet every snowflake beneath our feet whispers of repetition. Perhaps the true story of Earth isn't one of endings, but of intervals, long breaths between beginnings. And as we listen to the quiet hum beneath the cold, we start to sense that we're part of the next heartbeat waiting to unfold. In the basalt cliffs of the Atlantic seafloor, time has cooled into layers. As magma once surged from Earth's crust and met the ocean's chill, it solidified into rock and into memory. Locked within those dark ribbons of stone are tiny particles of iron, each one frozen in alignment with the magnetic north that existed the day it cooled. These tiny compasses, fossilized in place, allow us to read the shifting mind of the planet. Earth's magnetic field is not fixed. It flows like wind through liquid iron beneath the crust, generated by the restless movement of our planet's outer core. At times, this field weakens, stutters, and reverses. North becomes south and south north. These flips are silent to the senses, but profound in effect. The last full reversal, called the Brun-Hess Matuyama, happened nearly 780,000 years ago. Others came before it, sometimes close together, sometimes separated by hundreds of thousands of years. Volcanic plains in Hawaii, Iceland, and India carry this record. Scientists call it paleomagnetism, the study of Earth's ancient magnetic fields. By analyzing the direction of these preserved signals, researchers discovered that the flips are neither random nor evenly spaced. Some suggest a loose pattern, a rhythm roughly every 10,000 to 13,000 years, overlapping with solar cycles, ice ages, and climate transitions. What would it mean to live during such a reversal? The field would weaken for centuries, exposing Earth's surface to higher doses of cosmic radiation. Migratory animals, whales, birds, butterflies, might lose their internal compasses. Satellites could glitch. Auroras would spread to unfamiliar skies, and the shield protecting us from solar storms might flutter like a veil in wind. Yet there's no evidence of global catastrophe during these past reversals. No extinction pulse, no apocalyptic end. Life adjusted. Forests grew again, species adapted, and the magnetic poles found new homes. The flips may be disruptive, but they are part of Earth's invisible architecture. Today, our north magnetic pole is drifting rapidly toward Siberia, moving faster than any time in recorded history. Beneath our feet, the molten core continues its slow churn, writing invisible equations in plasma and metal. Whether a full reversal is near remains uncertain. But one thing is clear. Our planet remembers, and every rock cooled by ancient fire carries a whisper of direction lost and direction regained. Above the calm swirl of clouds, our sun beats with a rhythm both familiar and strange. Every 11 years or so, its surface stirs. Dark sunspots bloom, magnetic fields twist, and streams of charged particles pour outward. These solar cycles rise and fall like breath, shaping the invisible space around Earth. Most pass gently, felt only in the quiet beauty of auroras, but some bring more than light. In 1859, the Carrington event sent a solar flare crackling toward Earth. Telegraph wires sparked. Auroras danced as far south as the Caribbean, and the night glowed with spectral green. It was a minor storm by cosmic standards, and yet it disrupted the world. What if far greater flares have come before and may return again? Tree rings and ice cores hold clues. In the years 774 and 993 CE, sudden spikes of carbon-14 appeared in trees across the globe. The cause? A massive influx of cosmic radiation. No supernova was nearby. No volcanic eruption could explain it. Many scientists now believe these events were solar in origin, bursts of unseen flares from our own star. Some researchers have found that every 11-year cycle nests within larger cycles, grand minima and maxima that repeat over centuries. And beyond them, a mysterious long wave pattern that seems to echo every 12,000 years. It's still debated, still unclear, but hints arise: climate shifts, magnetic weakening, extinction events, all clustering near the crests and troughs of solar change. The sun may not cause Earth's resets directly, but its fluctuations add pressure to a delicate system. A weakened magnetic field, timed with solar extremes, could expose the planet to levels of radiation unseen in human history. And while we live beneath atmospheric protection, the signs are subtle: a shift in auroral zones, satellite disruptions, whispers in GPS drift. Looking back, we wonder what the skies of ancient civilizations revealed. Perhaps The northern lights once danced over Babylon. Perhaps legends of flaming dragons or chariots of fire were born not in metaphor, but in plasma. Today, we orbit a calm star. But calm is temporary, and somewhere in the data, the sun is still speaking. Through ice cores, tree rings, and flickering satellites, we are only now learning how to listen. Along the northern coasts of Canada and Siberia, ancient stones bear parallel grooves, scars left by rivers of ice that once scraped across the land. These weren't fleeting winter storms, but glaciers, towering walls of compressed snow, hundreds of meters thick, slowly grinding their way toward the sea. They moved with the patience of gravity, carving new landscapes, swallowing old ones, and pressing the memory of their path into stone. For over 2 million years, this rhythm has repeated. Ice advances, then melts back. Shorelines rise, then vanish beneath the waves. Forests creep across once frozen ground, only to be silenced again. At first glance, these glacial shifts seem unpredictable. But deep in astronomical records and sediment cores, a pattern unfolds. Not precise, but persistent. Earth's orbit is not a perfect circle. It stretches and relaxes over cycles lasting tens of thousands of years. The planet tilts more, then less. Its axis wobbles like a spinning top. These movements, eccentricity, obliquity, and precession, change how sunlight reaches different parts of the Earth across millennia. When these three cycles align, they trigger climate swings powerful enough to reshape the globe. Scientists call them Milankovitch cycles. During colder phases, glaciers stretch across continents, locking away oceans and ice. Sea levels fall, exposing land bridges and silencing coral reefs. In warmer periods, those glaciers melt, releasing fresh water, sediment, and memory into the seas. Each pulse redraws coastlines, shifts rainbelts, and invites species to migrate, evolve, or disappear. But it's not only the ice that remembers. The oceans play a slower song. They absorb carbon dioxide during glacial times, cooling the atmosphere. As ice retreats, the seas exhale, releasing that stored gas and nudging the climate into faster change. Deep currents carry cold water across the globe, setting weather patterns for centuries. Today, remnants of this cycle still echo. Greenland's meltwater slows the Atlantic conveyor. Antarctic shelves calve into the sea, and coral reefs in Australia reveal growth bands that match ancient glacial retreats. The planet, though seemingly still, is moving, not just in space, but in rhythm. We are living in the breath between advances. The glaciers have receded. The ocean is warm. But beneath this calm, the next inhalation is already building. And just like before, the earth will not ask permission. It will simply move, as it always has, in cycles written in ice and sea. On a windswept plateau in Siberia, paleontologists unearthed the skull of a tiny creature with sharp teeth and a delicate jaw. It wasn't a fearsome predator or a giant herbivore, just a small shrew-like mammal, barely the size of a fist. Yet its ancestors would one day rule the earth. Around 66 million years ago, it survived what the dinosaurs could not. Not every global reset arrives like a fireball. Some come slow, through poisoned air, choking oceans, or failing food chains. The Permian extinction, over 250 million years ago, unfolded not in seconds, but over tens of thousands of years. Volcanic eruptions across what is now Siberia released clouds of carbon dioxide and methane, warming the earth until the seas became acidic and the air unbearable. Over 90% of all marine species disappeared. Forests turned to ash. Only a few lineages endured, clinging to the edges of a hostile world. These extinction events act like filters. They do not choose the strongest. Instead, they favor the adaptable, those who burrow, those who live in shadows, those who can wait out centuries of chaos. Tiny creatures like lungfish, crocodiles, and hardy plants often outlast the giants. After each great dying, new forms rise from the survivors, reshaping the tree of life. The oceans hold many of these secrets. Deep below the surface, where light never reaches, some species remain unchanged for millions of years. Coelacanths, ancient fish thought extinct, swim in silence. On the seafloor, tube worms cluster around volcanic vents, living off chemicals instead of sunlight. These strange ecosystems remind us that life finds ways in the margins. Above ground, genetic evidence tells a similar story. Humanity's ancestors may have passed through a bottleneck around 70,000 years ago, possibly due to a volcanic winter or climate disruption. Only a few thousand individuals may have survived. From them, all modern humans descend. In that sense, we are the children of survivors, shaped not only by ambition, but by endurance. As we walk through Earth's fossil layers, we find not just bones and imprints, but silence. Long gaps where once vibrant ecosystems vanished. Each reset leaves space for something new, but never without cost. What rises next is always different, and sometimes what disappears never returns. So when we speak of Earth's 12,000-year cycle, we must also listen to the pauses, the quiet spaces where life thinned, held its breath, and waited. Because it is in those moments, not just the catastrophes, that the future begins to form. In the heart of Iceland, black basalt cliffs rise above steaming ground. Here, ancient lava cooled slowly under open skies, locking within it a frozen whisper of Earth's magnetic past. Geologists chip away at these rocks, hunting for the direction of tiny magnetic crystals, microscopic compass needles that point not north, but sometimes south. Every few 100,000 years, Earth's magnetic field reverses. North becomes south, and vice versa. This doesn't happen overnight. The transition can take centuries or even millennia. During this process, the field weakens, fragments, and shifts unpredictably. For creatures that rely on magnetism to navigate, from birds to whales, such chaos can be deeply disorienting. The last full reversal happened about 780,000 years ago during the Brunhes-Matuyama event. But more recent anomalies suggest the field has flirted with change since. Around 42,000 years ago, during the Lasham excursion, the magnetic field briefly weakened to just 6% of its current strength. Cosmic rays bombarded Earth's surface, possibly altering atmospheric chemistry and contributing to climate disruption. We find these records not in stories, but in stones. When molten rock solidifies, iron-bearing minerals align with the magnetic field at that moment. By analyzing volcanic layers from across the globe, Hawaii, Iceland, Africa, scientists have pieced together a jagged timeline of magnetic wanderings. What they've discovered is both curious and concerning. Reversals may follow semi-regular patterns, clustering around periods of global stress. Some align closely with climate upheavals, mass die-offs, and even collapses in early human population centers. The cause effect isn't fully clear. Magnetic shifts may not trigger catastrophe directly, but they could weaken Earth's natural defenses at precisely the wrong moment. Today, satellites monitor the South Atlantic anomaly, a region where the magnetic field is unusually weak. It's growing, and the North Magnetic Pole is drifting faster than ever, racing toward Siberia. Though no reversal is imminent, the signs are there, faint but familiar. If the field were to collapse or reverse again, our satellites would be exposed. Navigation systems could falter. Cosmic radiation would seep closer to Earth's surface. In such a world, the invisible would become painfully real. So we keep watching the rocks and the skies, because though magnetism is unseen, its echoes remain, carved into stone, carried in myths of celestial disruption, and perhaps still shaping the rhythms of our planet's deeper clock. High above the Earth's atmosphere, satellites silently observe the sun. What they see isn't just light, but movement, flares erupting, magnetic loops writhing, dark spots forming and fading. These sunspots, first recorded by ancient Chinese astronomers and later sketched by Galileo, mark cycles of solar activity that ebb and flow in roughly 11-year intervals. At the height of these cycles, solar maximum, the sun grows more tempestuous. Flares intensify, solar winds howl stronger, and streams of charged particles race toward Earth. Our planet's magnetic field catches these gusts, creating spectacular auroras, but also disturbing power grids, communication systems, and satellite operations. During solar minimum, the opposite occurs. The sun quiets. Fewer sunspots appear. Solar winds weaken. But this calm doesn't always bring peace. In fact, history hints that extended solar minimums may correlate with earthly hardship. One such period, known as the Maunder minimum, stretched from roughly 1645 to 1715. During this time, sunspots nearly vanished and the Earth cooled, entering what we now call the Little Ice Age. Crops failed in northern Europe, rivers froze, communities collapsed under repeated harsh winters, artists painted landscapes blanketed in snow, and historians recorded famines, plagues, and unrest. The cause was not solely the sun, but its silence may have played a subtle, chilling role. As we dig through ice cores, tree rings, and written chronicles, patterns begin to emerge. Spikes in solar activity align with warming intervals. Drops coincide with downturns. Civilizations, it seems, have danced, knowingly or not, to the pulse of our star. Today, scientists monitor sunspots with precision. Our current cycle, solar cycle 25, is still unfolding. Some predict it may be weak. Others suggest surprises ahead. Either way, the sun remains our great influencer, not just of light, but of life's rhythms. And so, we look skyward, not just for weather, but for whispers of what's to come. Because in the flicker of sunspots and the hush between flares, Earth may find the tempo of its future. The transition out of the last ice age was supposed to be a slow thaw, a gentle warming as glaciers retreated and life reawakened. But something interrupted that rhythm. About 12,900 years ago, the planet veered sharply off course. Temperatures in the northern hemisphere plummeted in mere decades. Forests died back. Mammoths and giant sloths vanished. The chill that followed would endure for over 1,000 years. This sudden reversal is known as the Younger Dryas, named after a resilient Arctic flower that flourished during the cold. It marks one of the most abrupt climate shifts in Earth's recent history, and its cause remains hotly debated. Some scientists believe the trigger was fresh water, a vast flood released from melting glaciers that spilled into the North Atlantic. This influx may have disrupted the thermohaline circulation, the great ocean conveyor belt that moderates climate by transporting heat. With that current stalled, warmth from the tropics never reached the north, but others suggest a more dramatic possibility, a cosmic impact, evidence of a layer of platinum, microspherules, and charred material in sediments across North America hints at a comet or asteroid strike. Such an event could have sparked wildfires, darkened the skies, and cooled the planet. Either way, the impact was enormous. In the Levant, the Natufian culture, early builders, foragers on the brink of agriculture, saw their settlements vanish, populations scattered. In North America, the Clovis people disappeared from the archaeological record. Across continents, ecosystems rewound to a glacial past. And then, just as suddenly, the cold lifted. Around 11,700 years ago, the climate warmed again, ushering in the Holocene, our current epoch. Agriculture spread, cities rose, civilization began. What the Younger Dryas teaches us is unsettling. Earth's climate doesn't always move slowly. Sometimes it lurches. And when it does, life reshuffles, rapidly, violently, and without warning. Could such a snap return? The answer is uncertain, but the fingerprints left in ice and stone remind us that even in an age of reason, we are still at the mercy of ancient forces. Beneath the glass of an old Turkish museum lies a parchment that shouldn't exist. Its lines are delicate but deliberate, coastlines inked with astonishing precision. The year was 1513, and the admiral who drew it, Piri Reis, compiled it from even older sources. What made this map famous wasn't what it showed, but what it implied. Along the bottom edge of the Piri Reis map is a faint, sinuous line tracing the coast of what appears to be Antarctica. But here's the twist. It's not Antarctica as we know it, buried under miles of ice. It's a depiction of the subglacial coastline, land revealed only by modern radar and satellite scans, centuries after the map's creation. Could this be coincidence? A cartographic error? Or was Admiral Rice transcribing something even older? Perhaps ancient charts passed down from a forgotten civilization that mapped the world before the last ice age ended. This map is not alone. The Orontius Phineus map from 1531, the Boitier map of 1737, both show southern polar features that were not confirmed until the 20th century. They depict river systems, mountain chains, and contours that should have been unknowable at the time. To skeptics, these are flukes, misinterpretations. But for others, they hint at a deeper legacy, that ancient mariners may have sailed further than we thought, recording what they saw onto scrolls, stones, or oral traditions later absorbed by Renaissance scholars. Perhaps it was memory, not science, that preserved the shape of lost lands. Echoes of pre-Ice Age coastlines, passed from generation to generation, distorted but enduring. These cartographic anomalies raise haunting questions. Who first mapped the Antarctic coast? How did they know? And if one piece of forgotten knowledge survived the cataclysms, what else might lie waiting beneath myth and map alike? As we turn each page of Earth's fragmented atlas, we're not just looking for places. We're searching for the memory of civilizations time tried to erase. High in the Peruvian Andes, where the clouds brush the earth, a wall rises in a zigzag of massive stone. Sacsayhuaman, a fortress perhaps, or a ceremonial ground, but more than anything, a mystery carved in basalt. Some stones stretch as tall as a truck, others weigh over 100 tons. yet they lock together without mortar, their joints so tight not even a blade of grass can slide between them. We stand before a question set in stone. How was this built? And by whom? Traditional archaeology dates the site to the Inca, yet even they spoke of an earlier people, the ones who moved mountains. Similar whispers echo from Lebanon, where the ruins of Baalbek hold the trilithon, 3 stones, each over 800 tons, forming the base of a Roman temple. No modern crane could lift them. No clear quarry marks explain their transport. Further east, in the arid soil of southeastern Turkey, Göbekli Tepe rises from beneath layers of time. 12,000 years old, possibly more, it predates agriculture, writing, and even pottery. Yet its T-shaped pillars, some over 16 feet tall, are carved with animals, symbols, and precise astronomical alignments. Why would a pre-agricultural people build an observatory temple complex that rivals modern understanding of the stars? From Japan's underwater Yonaguni Monument to the massive terraces of Ollantaytambo, these sites challenge our sense of scale and sequence. They suggest either lost techniques or lost time. Perhaps ancient engineers saw stone not as obstacle but as language. They carved calendars into temples, encoded sky maps into architecture, and aligned their structures with solstices, equinoxes, and lunar cycles. Not to dominate nature, but to move with it. If these were mere anomalies, we might dismiss them, but their global distribution tells another story, a story of knowledge, scientific, sacred, and systematic, hidden beneath millennia of dust. As we trace their chiseled lines, we are not just uncovering construction. We are reawakening the architecture of memory itself. On the Yucatan Peninsula, where jungle vines embrace limestone ruins, the temple of Kukulkan rises like a stepped pyramid, reaching for the sky. At each equinox, a shadow descends its flank, a serpent of light, as if the sky itself slithers down to greet the earth. This was no accident. The Maya built with purpose, aligning their structures with solar events down to the day. Their knowledge of Venus, eclipses, and sidereal cycles rivaled modern models, and they were not alone. In southern Egypt, buried beneath desert sand, lies Nabta Playa, a megalithic calendar circle older than Stonehenge. Here, nomadic peoples positioned stones to mark the summer solstice and the rising of Sirius, signaling the flood of the Nile. Thousands of years before dynastic Egypt, the stars already told stories of timing and survival. Further north, in England, Stonehenge's massive sarsins stand in solemn arcs. On Midsummer's Day, the sun rises perfectly over the heel stone. Its builders, too, charted the heavens, encoding celestial patterns into stone rings and burial mounds. The alignment of sky and stone was deliberate, perhaps essential. We move east to Angkor Wat in Cambodia. This temple complex, vast and symmetrical, doubles as a cosmic diagram. Its central tower aligns with the morning sun at the spring equinox, while its layout mirrors the constellation Draco. The heavens were not separate, they were a map overlaid upon the earth. These sites were more than observatories. They were interfaces, cosmic clock faces that helped ancient people anticipate the rhythm of life and catastrophe. Why the obsession with the sky? To them, the stars weren't distant. They were calendars, gods, and warnings. Solar cycles brought harvests, but also drought. Eclipses foretold change. Comets were omens. A disrupted sky was a sign of an Earth out of rhythm. When we trace the alignments carved into temple stones, we are not just seeing architecture. We are witnessing a civilization's heartbeat, measured not in heartbeats, but in solstices. And beneath their reverence lies a quiet anxiety, a belief that when the stars change, the world follows. Beneath the surface of scientific consensus lies an unsettling question. Does Earth undergo periodic resets, not by chance, but by design? Magnetic pole reversals offer the first clue. Geological records show that Earth's magnetic field has flipped hundreds of times, sometimes within just a few thousand years. These reversals are not gentle. During transition periods, the field weakens, exposing the surface to cosmic radiation and solar storms. The last major reversal, the Lachamp event, occurred around 42,000 years ago and coincided with mass extinctions and cultural shifts. But we may not need to wait another 40,000 years. Our magnetic field is weakening now, rapidly. Solar micronovas present another possibility. Unlike massive supernovae, these smaller solar eruptions don't destroy stars, but can eject large bursts of plasma toward nearby planets. Evidence of past solar outbursts lies in layers of radioactive isotopes like carbon-14 and beryllium-10 found in tree rings and ice cores around the globe. Around 12,000 years ago, a date echoed across our story. One such spike appears. Was it the cause or the effect? The theory of crustal displacement adds yet another layer. According to this model, Earth's lithosphere, the outer shell, can slip over the inner layers, rapidly relocating entire continents. This would trigger earthquakes, floods, and climate shifts in a matter of weeks. Though controversial, proponents point to ancient shorelines in Antarctica and tropical fossils buried beneath polar ice. The convergence of these phenomena paints a haunting picture. Earth's resets may stem from overlapping disruptions, magnetic, solar, tectonic, that crescendo together every few millennia. What makes this cycle even more unnerving is its timing. Many researchers believe the last global catastrophe occurred around 11,600 to 12,000 years ago, near the end of the Younger Dryas. If the clock is ticking again, we may not be preparing for the unknown, but for the expected. Still, this idea remains speculative. The evidence is compelling, but the mechanism remains elusive. Yet civilizations past left clues, carved in stone, aligned with stars, or buried beneath cataclysmic layers, that seem to whisper a single message: it will happen again. Along the icy expanse of Antarctica, a strange contradiction has persisted for centuries. The continent we know today, lifeless, frigid, remote, may once have looked very different. The first ripple of mystery appears in a 1513 map drawn by Turkish Admiral Piri Reis. It depicts the coast of South America with astonishing accuracy. But more curiously, it shows a southern continent that resembles present-day Antarctica without its thick glacial cover. Cartographers of the time had no satellite data, no access to aerial views. Yet somehow the contours match modern scans taken beneath the ice. Skeptics dismiss the Piri Reis map as coincidence or copying, but other documents, like the Orontius Phineus map from 1531, show similar features. a landmass at the South Pole, complete with rivers and mountain ranges, long before Antarctica was officially discovered in 1820. Fast forward to today. Scientists using ground-penetrating radar have uncovered strange formations deep beneath the Antarctic ice sheet, some symmetrical, others geometrically aligned. Buried peaks, circular structures, and grid-like ridges spark speculation. Are these natural formations or remnants of something engineered? The mainstream view holds firm. Antarctica has been frozen for over 30 million years. But some fringe geologists argue that its current ice sheet is far younger, perhaps only 6,000 to 12,000 years old. If so, it opens the door to a haunting possibility. A civilization could have existed there and vanished during a sudden crustal shift or global freeze. The extreme isolation of the continent has preserved more than just ice. Meteorites lie untouched for millennia. Ancient atmospheres are trapped in bubbles, and possibly, just possibly, ruins slumber beneath miles of snow. But exploration is restricted, limited by extreme cold, treaties, and international politics. If a civilization once called Antarctica home, its story remains buried, encrypted in ice, waiting for the thaw. Whether myth or memory, the whispers from beneath the ice compel us to ask, what history did we lose to the cold? Across the ancient world, myths and legends whisper of a time before time, a world undone by disaster. The Hopi people speak of 4 worlds. The first 3 ended in fire, ice, and floods. The 4th is the one we now live in, fragile, temporary. Thousands of miles away, ancient Hindu texts tell of cyclic yugas, cosmic ages that rise and fall with the breath of the universe. Each ends in upheaval, each begins anew. In Greece, Plato described Atlantis, a mighty civilization swallowed by the sea in a single night. He claimed the story came from Egyptian priests who had records of a cataclysm long before known history. The Maya etched their cosmic calendar in stone, with resets and recalibrations marking the end of eras. Aboriginal Australian stories speak of a time when the sky turned dark and water consumed the land. In Norse mythology, Ragnarok is not merely an end, but a cleansing before rebirth. All these stories, born from different landscapes and worldviews, converge on similar themes. The world ends, the world begins again. Are these tales simply reflections of human fear, a psychological echo of survival instincts, or do they encode real memories of past resets, passed down through oral traditions, carved into stone, sung by firelight? Modern psychology understands that collective trauma can endure across generations. We inherit fears we've never lived, remember events we never witnessed. This makes it possible that ancient peoples, scattered by continents but united by catastrophe, left behind warnings in the only way they could: myth. It's tempting to dismiss the flood myths, the sky fire, the trembling earth as metaphor. But when so many separate cultures sing the same song, we must wonder, were they remembering something we've forgotten? What if myth is memory, encrypted not in fact, but in feeling? We often walk through history as though it's a single thread, linear, tidy, undeniable. But what if it's more like a spiral, looping through epics we've yet to understand. Off the coast of Yonaguni, Japan, lies a submerged stone structure with steps, terraces, and flat surfaces so precise they challenge the randomness of nature. Mainstream science insists it's a geological oddity, but divers who've mapped the monument report clear signs of shaping. Corners too square, platforms too level, patterns too deliberate. Thousands of miles away, beneath the Gulf of Kambhat in India, sonar scans have revealed structures that resemble cities, roads, buildings, and artifacts buried under silt, dating back nearly 9,500 years. If these dates hold, they predate every known civilization. In the Andes, high in the mountains of Peru, Sacsayhuaman's walls are constructed of stones so massive and so perfectly interlocked that modern engineers marvel at the craftsmanship. There is no mortar. The stones curve into one another like a puzzle solved in stone. These are not isolated outliers. Across the globe, in Turkey's Göbekli Tepe, Bolivia's Puma Punku, and Egypt's Osirion, we find evidence that doesn't fit the model. Advanced construction, astronomical alignments, and sacred geometry hint at knowledge deeper than mere survival. It's as though different groups, separated by oceans and millennia, all awakened and then vanished. Why do we bury inconvenient data? Why do timelines get trimmed to fit the narrative? Some say it's academic inertia. Others whisper of lost chapters in our species' memory. But maybe it's simpler. Perhaps the Earth does reset, and with each reset, we lose the libraries, the cities, the songs. All that's left are stones, half buried, waiting for the next loop. The spiral of time may not move forward. It may orbit around us. At first glance, a stone circle or carved pillar may seem like mere relics of a bygone age, ritualistic, symbolic, misunderstood. But when we view them through the lens of astronomy, a different picture unfolds. Stonehenge, in southern England, aligns precisely with the solstices. Its giant megaliths, each weighing tons, were positioned to track the longest and shortest days of the year. It was not merely a temple, it was a clock written in stone. And it's not alone. In Egypt, the great temple of Karnak channels sunlight during the winter solstice through its towering pylons. Far to the west, in the highlands of Peru, the ruins of Machu Picchu include the Intihuatana, a carved stone believed to anchor the sun during solstices and equinoxes. Scholars once dismissed it as superstition, but now we recognize it as astronomical design. These ancient architects knew the sky was more than decoration. It was data. It held cycles of growth, drought, floods, and perhaps endings. In Chaco Canyon, the ancestral Puebloans etched a spiral into a cliff wall, positioned so that a dagger of sunlight would pierce its center only on solstice days. This was not art, it was calibration. What were they tracking so carefully? The 12,000-year cycle appears once more. Some monuments align not only with seasonal changes, but with long-term celestial events. The precession of the equinoxes, axial tilt, and even solar activity. Could these sky watchers have witnessed or remembered a prior collapse? And in response, built calendars not just for planting, but for warning? These alignments whisper of a memory encoded in stone, a message sent forward in time, waiting to be read. We may not fully understand their warnings, but the fact that so many civilizations, separated by continents, built sky-oriented structures all suggests they were watching something together, not just the sunrise, but what came after. Deep within Earth's molten core, iron flows like water, creating an immense magnetic field, a protective cocoon that shields us from solar radiation and cosmic threats. It is silent, unseen, yet essential for life as we know it. But this shield isn't permanent. Throughout Earth's history, the magnetic field has reversed itself. North becomes south, and south becomes north. These geomagnetic flips don't happen overnight, but when they do, they leave a trail. Volcanic rocks, as they cool, record the direction of the magnetic field like ancient compasses frozen in stone. In Iceland and Hawaii, layers of lava whisper of chaotic times when compasses would have spun wildly and auroras danced closer to the equator. The last full reversal, the Brunhes Matuyama, occurred about 780,000 years ago. But what's more startling is the pattern of smaller magnetic excursions, temporary partial flips, which seem to align with major climate shifts and extinction pulses. And one such excursion, known as the Lachamp event, happened just 12,000 years ago. During this brief reversal, Earth's magnetic shield weakened drastically. Cosmic rays poured in. The atmosphere changed. Some scientists link this to increased lightning, climate disruption, and even the rapid decline of species. Could this magnetic stutter have been part of a broader planetary reset? Beneath the Arctic ice, we find more clues. Tiny isotopes, beryllium-10 and carbon-14, spike in concentration in tree rings and ice cores around these events, hinting at a flood of radiation from space. These bursts leave fingerprints across the globe, and now we're detecting strange behavior in Earth's magnetic field again. The South Atlantic anomaly, a growing weak spot, suggests the core may be stirring. We don't know when the next full flip will come, but it's happened before. And each time, Earth changes, not with fire or flood alone, but with a shift deep in the planet's heartbeat. As we continue forward, we must ask, is the next magnetic whisper already beginning to rise? There is a quiet fear that sleeps beneath the waves, a memory too vast for books, yet etched into the seabed itself. In regions once thought eternally dry, we find ancient shorelines hundreds of feet below the surface. Along the continental shelves of Asia, Europe, and the Americas, sonar scans reveal cities, roads, and walls long hidden beneath the tide. What could have caused the oceans to rise so swiftly and so violently that entire civilizations vanished? One theory points to the end of the last ice age. As glaciers melted rapidly, a vast influx of fresh water poured into the oceans. But this wasn't a slow, gentle rise. Geological evidence reveals pulses, dramatic jumps of several meters within decades. One such event, known as Meltwater Pulse 1A, raised global sea levels by over 20 meters, possibly within just a few centuries. Off the coast of India, near Dwarka, divers discovered stone structures aligned with ancient Vedic maps, submerged under the Arabian Sea. These ruins may date back 9,000 years, suggesting coastal populations once lived where now only fish swim. In the Black Sea, researchers found a sudden change in salinity layers in marine life, hinting at a cataclysmic flood. Some propose that when the Mediterranean breached the Bosporus, seawater rushed in with unstoppable force, drowning vast lowlands. This event could be the origin of global flood myths, including the story of Noah. Across Pacific islands, oral traditions speak of walking forests swallowed by the sea, of gods abandoning shorelines, and of stars reflected in salt where villages once stood. These stories are more than metaphor. They are encoded memories of real upheaval. Satellite altimetry and ancient pollen samples now show that the ocean's mood can shift fast. In places like Doggerland, a now submerged plain once connecting Britain to Europe, we find mammoth bones and human tools lying beneath the North Sea. When the waters rise, they don't just erase land, they erase identity. Boundaries vanish, borders blur, and yet, beneath those waves, something persists. A whisper from the deep, reminding us that what we call permanent is only briefly above sea level. High above us, the sky holds more than stars. It holds scars. Across continents, ancient texts and carvings speak of fire from the heavens. In Australia, Aboriginal stories tell of the sky falling. In the Arctic, Inuit elders speak of great fires sweeping the snow. And in Central America, the Popol Vuh recalls a time when the sky god sent burning stone upon the earth. For generations, these were dismissed as poetic imagination. But now, science begins to listen. We start with a layer of glass, microscopic, shiny spheres found across North America, Europe, and parts of Asia. These tiny particles, known as impact spherules, form under extreme heat. They're found alongside shocked quartz and magnetic grains, indicators of an atmospheric explosion. The dating? Roughly 12,800 years ago, a time of sudden climate collapse known as the Younger Dryas. Around this same time, temperatures plunged, glaciers halted their retreat, megafauna disappeared, and across the skies, something had changed. The Younger Dryas impact hypothesis suggests fragments of a disintegrating comet struck the Earth's atmosphere, triggering wildfires that blanketed the globe. Charcoal layers support this, found in ancient soils from Syria to South Carolina. A world that had been warming rapidly froze again, as if hit by a cosmic reset. In South America's Atacama Desert, vitrified rocks show signs of intense thermal energy, likely not from volcanoes, but from a high-altitude burst. Such air bursts, like the Tunguska event in 1908, release more energy than an atomic bomb. But it's not only comets we fear. The sun itself can turn hostile. Solar superflares, though rare, can eject charged particles with devastating force. If aimed at Earth, they can ignite our atmosphere's upper layers. In 774 AD, a massive solar event left a distinct carbon-14 spike in tree rings worldwide. No fires were recorded, but what if a larger one had struck? The myths may be memories. The fire from the heavens may not have been gods, but forces far more ancient and far less forgiving. Even now, the sky waits silently, holding within it the fire that once scorched the earth. The earth holds memory in silence. Beneath cities and oceans, beneath layers of soil and stone, lies a clock. One that does not tick by seconds or years, but by epochs. This clock does not chime, yet it leaves signals behind. Sediment disruptions, fossil disappearances, isotopic swings, and patterns of crustal unrest. In the Canadian Shield and across Eurasian bedrock, scientists have mapped strata dating back hundreds of millennia. Within them, sudden breaks appear, not gradual erosion, but abrupt collapses, flood marks, and ash deposits. Over time, a rhythm begins to emerge. Every 10,000 to 12,000 years, Earth's geological record seems to hiccup. It's not always fire, not always ice, but always change. Take magnetic reversals. Earth's magnetic field flips irregularly, but with intriguing clusters. Around 12,000 years ago, it weakened drastically. Not a full reversal, but a geomagnetic excursion. This event, known as the Gothenburg excursion, may have stripped atmospheric shielding, letting cosmic radiation spike. We find the traces in tree rings and ice cores, a pulse of energy from the sky, recorded by the Earth itself. Crustal displacement theories, once fringe, now gain attention. Some suggest Earth's outer shell shifts slightly over millennia, pushed by internal mass imbalances or external gravitational nudges from the moon or perhaps even distant planetary alignments. While full pole shifts remain controversial, regional slips have been observed. Land rising in Scandinavia, shorelines altering in the Pacific. These are not myths. They are movements etched into coastlines and seafloors. We also find strange deposits, desert sands far from any desert, tropical pollen buried in frozen peat. These speak of rapid relocations, as if Earth's axis swayed or her balance shifted suddenly. And beneath it all, the telluric pulse continues. Whether from core convection, mantle plumes, or celestial cycles, our planet seems to breathe in deep time, an inhale of calm, an exhale of change. We end not with answers, but with a deeper awareness. This earth is not still, it is not safe, and it is not ours to control. But by listening to myth, to sediment, to sky, we may yet learn the rhythm, not to escape the next reset, but to greet it. Eyes open, hearts prepared.